So, can you hear me? Yeah. So, myself, Kiran Kasyap, and I have also co-authored a book along with Vivek. Actually, yeah. Yeah, thank you. So, I have also co-authored a book along with Vivek. The couple of books. One is TDD for Spring Boot microservices, and another one is Metrics for Agile Product Teams. And along with this, I like to blog, and I'm also an international conference speaker, and I've spoken in XP Canada and Regional Scrum Gathering and Agile India. And yeah, apart from this, I've contributed to open source, and I'm an open source contributor. And I'm also a member of TechCode Circle, like Vivek mentioned. So we help Scrum Masters and managers to be more tech savvy, and adding to that, we help them to do exercises to get the community of people and improve themselves. And apart from this, on a personal note, I love playing badminton and I love traveling. So yeah, that's about me. And don't worry, we'll try to make sure you'll go to lunch. I saw some scary faces when when she told you can extend till 1:15. Don't worry, we'll try to make sure you'll go right on time for lunch.
Okay. So how will we spend the next, not 1.5, so think of it as next 1 hour, right? How will we spend the next 1 hour and 7 minutes or 6 minutes to be exact, right? We'll start with some fundamentals so that we can all be on the same page. Otherwise, I'll be talking some rubbish and you may not be understanding. So I will start with the fundamentals, bare minimum fundamentals, and then since this is about talking about the effectiveness of test cases, particularly unit test cases, we will talk about a not so good but popular method. Everybody raves about it. You ask a question, everybody talks about that method. So we'll talk about something which is very popular. I assure that every one of you will know that method, right? We'll start with that, and we'll try to find out what all bad things can happen when you continue following that or keep that as important. And we will also do some activities just so that you don't fall asleep, right? And we will next go to a not so popular but good method, right? A method which is not so popular for analyzing the effectiveness of test cases, unit test cases, but it's actually a good method. We'll talk about that, we'll introduce you, we'll show you some demos, and also we will do some activities so that, next is lunch, no? So we want to keep your mind away from food for some time, right? So for that we will do some activities. So this is going to be the agenda, and let's get started with the fundamentals, right? So the most fundamental thing that any software engineer talks about, what is code? Anybody? Code is garbage. Yes, thank you to Santosh. Okay. Okay, what kind of garbage is code? Outer ring road garbage. I like it. Yes. Sorry? Yes, garbage is in our mind all along so far. Okay, let's go further. Tells the computer what to do, right? And it is typically written by a coder or developer. Whoever writes code, we'll call them a coder, right? So people who are writing automation tests, you are also coders, by the way, right? And it's typically written in a programming language, though you can write in a low-level programming language, microprocessors, bytecodes and all. But still, today we are sophisticated in industry. We write in high-level programming languages like Java, Python, etc. And don't worry, I'm not going to scare you with a lot of code. We are not going to make you code. We promise not to do that, right? So we called this a workshop. So don't expect us to scare you to write some code and all these things. However, we break some promises. We want to show you some code, right? So this is an example of a code. Any guesses what it does? Finds whether some number is an even or odd, and if it is even, it returns a string called even. If it is odd, it returns a string called odd, right? This is an example of a source code. And what is a test? Okay, any other definition? Good. Yes, to check whether the code is working or not. So test is something that we do to verify if the source code is working right or not, right? And this can be manual or automated. And automated test is also code. So there is an example of that also. This is strictly not a test, but it acts like a test. So what does it do? Any guesses? So in the first line, right, here I am trying to pass the value of 2 to the method that I showed you before. I showed you some code before, right? Something that tells me whether something is even or odd. I am trying to test that method with a value of 2, and I am already writing that expected result is even, and I am saying that I am checking whether the expected result is equal to the result that I got from the execution or not, right? And this is a sort of a test case, though the syntax and all, depending on the framework, it will change, but this is fairly a test case, right? And this is basically, if you see, this is also code, right? It doesn't look very different from code actually, right? This is also code. Now, if you talk about test cases, there are multiple levels of test cases. If you had attended Anand's talk in the morning, you would have seen the test pyramid, right? So here in this particular talk, we are going to talk at the very lowest level of the test, which is the unit test. And okay, let's, before going into unit test, there are two types of testing that a tester can do. We use colors to denote that. Any guesses? What are they? Two colors we say.
Black and white.
Yeah, black box and white box. Yes, exactly. What is black box testing?
Say functional testing.
Yes.
Then tester don't have any idea about what is what's happening.
Yes, you do not understand the internals of a system, and you are sitting outside the system and treating it as some black box about which you know nothing, but you have some expectations from that black box and you test that, right?
So it's just not the functional testing, it's usability, UI, UX, everything. Not necessarily functional, because I just wanted to make a note of it.
Yeah. Yes, right? So that is black box testing. So most of the testing that traditional testers do is black box testing, right? We don't go and ask, hey, can you show me your source code? I'll look at it and try to test it. No, we don't do that. We are not even allowed to do that in some organizations actually. Why are you asking for code, man? What is your job, right? Whereas white box testing is different, where you have knowledge about the internals of the system and you use that knowledge and try to capitalize that knowledge to break the system. In your testing process, not in production, right? In your testing process, don't do that in production. And when you do that, you can do some kind of testing, which is a little superior in terms of the coverage and things that you can do. It gives you superior protection against things, and that is called a white box testing, right? So typically when we talk about testing, you are expected to have these two flavors over a period of time. Initially, you may start with black box testing as your predominant job, but if you want to really prevent bugs, you basically go deeper into the white box testing. And there is an additional dimension also. It's not just the testers who will do all these things. Developers are expected to put some tests. And typically the tests that the developer writes, they are white box tests, right? So unit test is the lowest level of test that you can write, and that is a white box test because they know the code and they're going to write a test for it, right? They know the internals, what's going to be the input, what's the service that I'm going to call, all these things they know, right? And when you talk about unit tests, everybody understands unit test in different ways, right? Most common definition that I see of unit test is the testing that the unit developer does before saying that the story is done and giving to tester. That is unit test. Many people think that, right? So we are not going to talk about that kind of testing here. We're talking about unit test is nothing but it is a test that verifies the smallest piece of code, right? It can even be a single line of code, that's fine. But any test that verifies a smallest piece of code, that is a unit test. One level above that, we generally call it integration test. Some level above that, they are end-to-end tests or acceptance tests. And then there is this manual exploratory test that Anand spoke about in the other talk, right? That's how it goes. So now that we know what is code and what is test, let's talk about good tests, and particularly good unit tests. Why should you know about all these things? We don't care about, we don't even see code, right? Why should we know about all these things? It's developer's job. Yes, it is always possible. See, has anybody heard about the term called XP, extreme programming? What does extreme programming mean? Any guesses? Or what do you say? What do you understand about it? There is some extreme in it. So it's a concept which is tried by a guy called Kent Beck in India, not anywhere else. It was done, initial run was done in India, in Hyderabad, in Microsoft Office. That is where one of the experiments, in the early experiments was done there. What they did was very simple. Take any good practice, take any common sense practice, right? Testing, good practice, bad practice. Good practice. Integrating code before releasing, good practice, bad practice. Good practice, integrating everybody's code and creating a single product and releasing. We don't want to release 10 products because 10 teams are working on it, right? Take any good practice and take it to the extreme. Dial the notch to probably a 10 out of 10. Take it to the extreme, and what you get is XP. Example, testing. When do we, testing good practice? We generally do testing after writing the code, probably after the build is done, not just writing the code. We write the code, compile it, build, and probably deploy to a server, and then a tester is given that URL and they can do it. That's traditional testing. Now make it extreme. What is the extreme thing that you can do? Write a test before you write even a single line of code. That's test-driven development, one of the XP practice. What did you do? You took testing, a common sense, no-nonsense practice, and intentionally made it extreme, right? And that became test-driven development. So far with me, is my pace okay? Do you want me to change the speed at which I am speaking? You're able to follow me, right? Okay. Similarly, integration. Integrating code before delivering. It's a good practice. Common sense practice, no problems. Everybody understands that. Now intentionally take it to the extreme. Instead of integrating 10 teams code one day before the release or 1 week before the release, I will integrate every single commit that a developer makes. That's continuous integration. That's intentionally taking the integration to the extreme. That's called extreme programming. One of the practices is CI. So XP talks about good test cases, and unit test cases are the ones that will lead you to TDD. Right? Now, let's talk about what is a good test. Right? So coming back to the point of why should we know about it as testers? About this code, this test, unit test, and all these things.
Validity is also one of the constants that you have to take care of.
Yes. Validation, it helps you in validation. Second thing is, there is one more practice called pair programming. One interesting thing happens here where there is a wall between developers and testers in a traditional sense, right? Testers and developers are actually arch rivals. We don't talk to each other and we shoot arrows using political lines of control to each other, right? That's what we do, right? Yes. Take that to extreme, removing the walls to an extreme and say, any user story, anything you develop, a tester and a coder. Sometimes it's fluid also, but I'm taking a less extreme version. Tester and a coder sits together. Tester writes a test and coder passes it, TDD style. It's called ping pong programming. That is also another way. You can look it up. I'm telling a lot of things to you. This is why it is important. If you understand this part of what is a unit test and you can look at the unit test reports that your CI servers produce and make sense of it, look at the coverage reports that your CI servers produce and make sense of it, you could actually come up with better test cases than what you are generally doing because you will understand the internals of the system better. And you can also gain confidence. You can ask the developer, hey, this particular scenario, how are you handling it in your unit test suite? I don't want to catch it 2 days before the release when I'm testing in an exploratory test. I want to catch it in your CI server. Can you include this scenario into your test case? These things and all you can do. That's why it's relevant for the testing community also. And of late it is becoming relevant because TDD is becoming the way of life for many of the companies. Right? There you can actually play a part with your testing hats. That's why we are talking about this. So now what is a good test? Good test has 2 things. First, it has to call what you are trying to test. Basic requirement. If you're testing something, you at least have to call it in your test. Right? Second thing, it has to verify if it is working fine or not. It has to use the result. These are the basic 2 things. It's common sense, but of late, not of late, since beginning, even I have written such tests where you will call and you will not verify. And I have seen at least every time I'm consulting with some team, some company, some team, right? I see a test case called assert true or assert equals true, true. That test case is a use of everybody's time, computer's time, CI server's time, everybody's time. That is not going to accomplish anything. That is just going to probably prove that your testing framework is working, which they have tested anyways. You are not going to test, you are not here to test JUnit, right? So that is also there. So we are going to talk about these 2 things heavily today, right, in the upcoming parts. So we sort of got the fundamentals clear, right? We'll do a small activity so that you don't feel left out. You have some practical understanding of what we have spoken so far. This becomes a feedback to us also, whether we spoke right things or not. So this is the first challenge. There is a code and there are 3 possible tests, and you have to tell us what is the right unit test for the particular code. Confusing, no? Second one, okay. Who is confused? So much of code, I don't want to look at it. This is not my job. No? Okay. I was warning him that I should not fall in, he should not fall into this, whatever it is. Now I'm trying to fall into it. There is a small hole for fitting the plug point. So, any guesses? Or
All three can be correct because we also have to take into consideration other possibilities.
okay. Okay, but what is the test case that, okay, let me rephrase this question. Oh, yeah. What will the test case that will pass this code, assuming that this is the code? The second one passes the code, right? Any questions, confusions about this point? No. Okay, let's check ourselves again. Sure? What does the first one do? It sends some number 3, 4, 5 and then it checks whether, what does it even do? Do you think it's a trick question?
Yeah.
What is the trick here?
You are only returning the, you are not returning the namaste part in any of the letters.
It's actually nothing. So actually, when we prepared this slide, 10 minutes before, 10-15 minutes before this talk was scheduled to start, and somehow I wrote namaste there and hello here. Right? It was supposed to be namaste and namaste, right? So second one again, right? That's the thing. Actual answer is none of these, but actually if namaste was here, the second one would be the case. So now you know what a good test case looks like, how a test case looks like. You're not afraid of looking at tests anymore. Supposedly you're not afraid of looking small code snippets anymore. We'll proceed further from here. So, yeah.
So till now we understood what is code, and a simple code we understood, and how to test that code by writing a code. We call that code and we pass some value and we assert it, and that's how we test. Now Vivek spoke about TDD, extreme programming, continuous integration, all that stuff. So now let's come to reality, right? Who has answer for this? Dash is the metric used to force the developers to write unit tests. Nice. Yeah, correct. Anything else? Sorry?
Metric.
TDD.
Metric is a measure.
Okay,
Code coverage.
Yeah. So yeah, that's the answer. Ken. So code coverage. So what is code coverage? Anyone has any answers? Yeah.
When you execute your functional or any test, whether those lines of the code what developer has written is getting executed or not.
Yes.
Let's say we have if block, whether else block is getting executed or not.
Yes. Exactly. So I'll. Sorry.
People have to start applauding. I don't know what's
Yeah.
wrong with people.
Basically, we need at that moment in time, for example, like in Salesforce-based application.
Yeah.
While we're deploying the code into the production part, at that moment in time, more than 74.37% ratio is required in order for a code coverage.
Yes.
At that moment in time, this particular
Yeah. Generally, yeah. That's what they say. We have to have at least 85% coverage. Otherwise, we are not going to. We're not going live, right? So I'll just use a simple example to tell you guys what code coverage is. So let's say this is our source code. It has around 10 lines of code, and we had a test suite which will test this this source code. And now while it tests, it only tested like 3 lines of code in that. Now what is the code coverage here? Any guesses? So we had a yes, 30% code coverage. Yes, simple. So this is what is code coverage means. So generally we see many organizations enforce quality. They make sure that we have a good quality. We can maintain if we have like let's say 90% of code coverage or 85% of code coverage. If we don't test 15%, it's okay. We can take that. So that's yeah.
Compared to what, when you call 30% or 60%,
Yeah.
does it depend on the intelligence of a person who is testing it as well? Code coverage part? Are we touching it?
So here I meant only unit tests. So we showed you the unit test actually. So when the test ran, it went to that. I'll show you an example.
Branch coverage and all those things.
Yes.
Yes.
There are automated tools that can automatically calculate.
So any questions till now? Okay. So let me give you an activity. Calculate the code coverage. It's not a very complex problem. Simple code we'll give, and try to answer what is the code coverage. So first line in the first box you see, that is the source code, and this is the test which will test that source code. Now what is the code coverage?
Line wise.
Line wise, yeah. 100%. Okay. Any other cases? 99%. Okay, almost there. So, do you mind explaining how? Sorry, you had? Yes, it is possible, but most of the times, no.
So in this
In this
case,
case, it's possible. So it is possible, 100%.
No, how about if X is negative?
Sorry.
If X is negative, then it is not 100%.
so when we talk about code coverage, it's just about the number of lines touched by the test case, not the functional coverage. We generally say, no, these many use cases are
Scenarios,
there and
yeah.
scenarios. We're not talking about that. It's just the number of lines touched.
Yeah, it just touches the line. We don't care whether this test is correct, good, bad. It is just touching or not. That's the question. So it's 100%. Like you told. Do you want to explain how it is, or? Yeah.
Because if you look, we are covering both if statements, right?
Yes.
We are going into if and also else part.
Yes. So
Anyways, any function called is also a call.
yes.
Like that line is getting interacted.
Yes. So I'll try to explain. So this is the test function. So it is test even or odd, and you're saying even or odd. We are calling that function in the in the second line, and we are passing 2. So now we are going there, and now even or odd we are passing 2, and yeah. Sorry. Yeah, you have this right. Hey, which one? It's not. Yeah. So here I am passing 2 for this function, and now the x is 2. Now 2 more 2 is equal to 0. Correct? So now the statement is true. It's returning even. Now if you see it has covered only this line. And now let us come to the next line. Even or odd, 3. Now the same function is getting executed. We are passing 3, and now 3 more 2 is equal to 0. Now the statement is false. So it's coming here and it's returning odd. So now this test, if you observe, it has covered 100%, 100% of the lines. So now we can call this test as 100% code coverage, right? But there is something wrong with this. I already showed you the answer, but if you guys can guess the answer, what it is. Like, she already gave a clue when she answered last time. If you guys have any other answers, why this test is not good?
The assertion is missing. I was about to tell before you.
Yes. Yeah.
You told in the previous
Yes,
slide
yes.
that assertion should be.
Assertion is not there. Anything else?
So what do we mean when there is no assertions? What does it mean? We are not checking anything at all.
There is no feedback.
We are just calling and leaving it. Okay.
Yes. I'm just driving car. I'm not checking whether, it's actually driving. I just sat and came out. Something like that. Now, I use the assert statement. Now, is it a good test case? Not complete. What is not complete? Yes. It is not testing the actual value it is expecting. It should be something like, it should be something like this. So it should assert equals, it should assert, I should get a return of even when I pass the number 2, or I should get a odd if I pass number 3. Here, if you see, I'm giving specific number there. So that is important. So we are using specific scenario to test whether the function is behaving as expected or not. So till now, any question?
What's the difference between, I think it will help other people as well to
Yeah.
understand, with the single equals and double equals and triple equals. There's a triple equals in JavaScript as well. Right? So what's the difference?
Single equal is just assignment. It's every language treats it differently. Single equals is just assigning, but when you want to check something, you use double equals. When you want to check something more strictly and stringently, you use triple equals, but that's depending on the language.
I think 3 equals is for the strict equality, and double is like
Not so strict.
Equality.
It just equals in
Yeah.
no. I think it's the data type which matters for the triple equals.
Yeah. Lot of other things also
Equals
go
is
in.
the
Yeah.
number, But the integer, that's triple equals.
Yeah.
So type
You can even have the objects and all equals.
So now this has 100% code coverage, and it also has a good test case written. So what I'm trying to say is it's easy to meet 100% code coverage and write crappy test cases, right? And that is why a code coverage as a metric is a problem, because some management will come and enforce this rule on testers. I mean developers, and they just write some test cases, and they know a lot of tricks. We just showed you a couple of things, and developers are even smarter. They just know how to get that magic number and just push it to the tester, and ultimately the responsibility will become will come to the tester to make sure the things are working correctly. And we have this lot of tests running in your system which actually doesn't make sense, right? So this is what they only asked for 80% code coverage. They never asked us to write meaningful test cases.
You know what? I'm transfixed on the look of her.
Yeah.
They asked it. Yeah.
Right. And why we are telling this, so that even you can give this feedback to developers. Go check how the test cases are written. When you see, you often complain, right? Testers, developers, they don't even test the basic scenario. They push it on us. You can go and see what is the test they have written for this basic scenario. Give them this feedback, right? This to and fro over a period of time, you can have a good unit tests, written, and and it cannot be solely dependent on you verifying all these things manually. So so what is wrong using only code coverage? Like, I'm just going to tell whatever I told you right now. So one thing is, it only ensures that people write tests. So somebody came and forced them to write test cases, and they are writing it, and nobody checks whether they are writing meaningful tests or not. And now it does not ensure quality of tests. And easy to write bad test. Like I told, somebody is pushing, we have this deadline and you have to do something, and you cannot push the code because we have 85% code coverage. Until then you cannot push any code, and they do something, and then they push the code. And there are some code where you cannot meet 85%, so they change a lot of things, and somehow they manage and change some functionality, and that will break something else somewhere. Yes. Yes, jugaad. And also, whenever when you say this 85% code coverage, you have some machine which will run to your entire code base, and then it shows you result, right? Here also you are utilizing all these machines which will go for waste actually, because you don't trust these tests anyway. But why to run these and wasting money on these and time as well? Until this in CI/CD, they would have implemented this step there, and it waits there for a lot of time to just to see it meets 85% code coverage. And these are all the problems with using code coverage as your metric. Now, how do we deal with this problem? So that's what we are uh,
So we should abolish using code coverage, right? No? That's what this guy spoke about so far, no?
There won't be any money coming to us.
No? Code coverage is, no, not the in thing. It's like MySpace, right? It's gone. Gone are the days where code coverage. We are not saying that. We are not saying that. Code coverage is a useful metric to see whether people are writing tests or not. When you start with that unit testing journey with your team, code coverage is an extremely useful metric, which will tell you whether people are actually having trouble writing test cases. So don't go and say that, okay, we will not use code coverage from today. Don't do that, right? And to add to the point of what he spoke about wasting system resources and all, right? Imagine you have 10 test cases which are useless test cases. Like we showed a lot of useless test cases, right? 10 test cases, each take, let's say, maybe together it takes 1 second, let's say. And every time you commit your code at any developer, not just that person, any developer in your team, let's say it's a 100-member team. Each time a developer commits code, a CI server is going to spend 1 second using some computer's resources. Probably you have it on the cloud, so you are going to pay AWS for that compute time. And 1 second every CI, and how many CI builds will be running based on how much commits you will do. That itself is actually a pretty big cost saving, if you see, if you don't run useless tests, right? And also, second type of cost saving is you are waiting unnecessarily for that useless test to complete. Otherwise, you cannot even deploy it to some place. That waiting is also another cost, right? Typically, the tester ends up waiting here, right? So, if you wait, let's say, same 1 second, every CI, every build, a tester is waiting for something to be tested. Take that tester's salary and probably, divide. I don't know how to do that exactly, but do it to 1 second, and then count the number of testers, and that is a cost that you are incurring from a financial perspective. That's huge. No? For every single commit. That's bad. So now, how do we get out of this mess? Because the initial problem is that I have written code, I don't believe that the code is working, so I write tests. Now, this test is also code. Now, how do you know whether you have written this test correctly or not? You cannot ask another person to come and test, then it will be like this, infinite loop. Right? It will be that nested Russian also, one after another. You will never, it will never end. So where do we end this, this quest for quality test cases? Is where we are going to next, and that is where this mutation testing as a technique and also metric. There is a metric called mutation coverage we will talk about. That is where it will come into play, and we will also show you, and we will give you sample projects which you can run directly on your browser, so that you can go and demonstrate the same whatever you have learned to your teams and ask them to experiment and come back with a mutation test report. Right? That's what we are going to cover in probably next 40 minutes. Right? So let's start with what is a mutation testing. Mutation testing, if you see, the blocks are the same. There is a code. The far right there is a code, and then there is a test suite. Right? This is sort of a set of tests, and these two are there, and the test is going to test the code. Now we are putting a third actor in this picture, which is called the mutation testing tool. This is typically open source, so every programming language, mainstream programming language, has their own mutation testing tool. For JavaScript based work, you have something called Striker Mutator, and for Java there is PyTest, and for .NET there is something, I don't know the name of it, but there is a mutation testing tool available open source without paying money for every mainstream programming language. So you put that there. And how this will work is, first step, this will take a copy of your code. So this sits in your machine. Assume that you are running it in your local machine for now. Then we will talk about how to run it in a central server. Assume that you are running it in your local machine. It takes your code, because it has access to your code, it takes your code and puts it in a temporary folder. It copies all the code into a temporary folder, keeps it. So it doesn't actually go and touch the code. And in the temporary folder, it injects some bugs, known intentionally. What it will do, maybe it will find a plus and it will silently go and change it into minus. In the source code, not the test code. In the source code, wherever plus was supposed to be there, I went and changed it into minus, right? And the next thing it will do after creating so many bugs is to run the test suite. Now, with the intentional bugs, will the test pass? Should the test pass or fail? Good test should fail, because we know that bugs are there, and the test should fail, right? And it will take account of how many tests or how many changes survived by test not failing, and it will give you a nice report. So check if the tests fail. That's the third step, right? You do this over and over multiple times, the tool will automatically do that. You can also do it manually, but it's little tedious and you cannot go deeper. But automatic mutation testing tools are very common and it's easily available, open source. You can just add one NPM library and it will start using. You can start directly using it. That is available. I'll go a little in detail about it. Same code example. I hope you are not still scared by this code, right? So same even or odd. And is this a good test case, bad test case? Just a refresher. Bad, why?
No assertion.
Right, assertions are there.
Oh, sorry.
Yes, there are no proper assertions, useless assertions basically, right? So we know for a fact that this is a bad test, right? So let's take one specific example and see how a mutation test can work here, right? So what this tool will do is, I'm going to show you two possible changes that a mutation testing can do. So one thing is it's going to replace the percentage with plus. Now what will happen? The entire code will be x plus 2 equal to 0. Right? Now with this particular change, when you run the test, will it pass, will it fail? It should fail, but it will pass, because what are you checking here? You are checking whether it is returning not null or not. You are not checking anything meaningful. So plus 2, minus 2, whatever. This particular function theoretically can return only two values, even, odd. Can it return null anywhere? It cannot return null. And what you have done? You have done assert not null. Right? So by default, this test is going to pass. Both these lines are going to say, hey, everything is good, hunky dory, everything is happy. Now, because of these two tests passing, right, this bug has survived. Right? This mutation, we call it as a mutation because they wanted some name, so they called it mutation because you're mutating the code. So this mutation survived. So now we know that this mutation has survived and this test is not covering that particular mutation. Second possibility that it can do is it will replace equal to with less than. Similarly, will the test pass or not? There is a equal to operator. Instead, what it will say, if the modulus is less than 0, same, the test will pass because it's never going to return null anyways. So this also survived. So if this is all that the mutation testing does, for example, in this one run, it will check, I created two mutations and none of them are killed, both of them survived. So my mutation coverage is 0%. Right? Do you want me to repeat this concept? Clear? Right? I created two bugs, two of them survived. So it's 0% mutation coverage. This means the tests are terrible. Right? Your tests are there, 100% coverage, that too. See, this is a 100% coverage test. And this is a terrible test because it has 0% mutation coverage. Right? This is what it does at a very high level. And if you take a code base which has multiple files and multiple test cases, supposedly you are writing unit test cases, so there will be multiple test cases, and this problem can blow into a very complicated stuff. So you need probably a good report for you to see what exactly failed, what did not fail, how it works, how did it not work and all. So what this, I am going to show you an example of a report created by JavaScript tool called Striker Mutator. So these are bad tests, we spoke about it. This is how it looks, right? Maybe I can show you live also. Hopefully I am still connected to the internet. Let me just check. Yeah, looks like I'm connected. Yeah, so generally JavaScript based code, you use Striker Mutator. That sort of has become the industry standard for mutation testing. For Java, it's PyTest, and .NET, there is some other code. But any flavor of, even TypeScript code, you could still use it because ultimately TypeScript becomes JavaScript in the process. So if you see, this is your entire directory, which you can see in your Git repository also, but this is the directory structure. And in this, each file, it has done a mutation score. You want to take this or should I take? Yeah. So this basically says that ultimately 57% of the bugs survived. Sorry, 57% of the bugs were killed. Okay, whatever is remaining, that some 33% of the bugs were not killed when the mutation test ran on it, right? Bad in math, sorry, right? So components, this is another, even in single file wise you can see what it did. So I'll show you one example of what it did in this particular file. So in this particular file, if you see, there are a lot of dots, which means these are the places where it did some change. And you can even go and see what change it did and what failed also. So I'll show you one example. Here, if I click on this, what it does is, its actual code was drink.amount greater than 0. What it did is, it changed it into less than or equal to 0, and the test passed. So test did not catch this error. So it says that equality operator survived, covered by 4 tests, and it will tell you which test passed also. If you see, these are the 4 tests in your test report. In your Jenkins, you can clearly go and see. These 4 tests are supposed to cover this, but these 4 tests passed anyways. Now you have a way to actually either add additional 1 test so that the test suite will fail, or change these tests so that it will fail whenever the less than equal to come. So you can directly talk to a developer and say, hey, this test case is missing here. Right? That is one thing. Or developer themselves can do that also. I'm not saying you should do that. Right? That is possible. Similarly, I'll show you another example. In the same line, see, it did actually 6 modifications and it results reports. It reports the results, right? Second thing what it did is it made it into greater than or equal to instead of equal to, greater than. Third it did was it just changed the entire expression ring dot amount greater than 0 to directly false. Still it passed, the test passed. Then it went even further. It went into true and nothing. It just catered into undefined function. Still it passed. Right? It basically does multiple things on the same line and it says that all these 6 are survived, which means these mutations have to be killed by your test suite. This is actionable feedback that a developer can take to make sure that your test is good, right? And it does not just show what is failing, you can also see what is killed. I have just not enabled it. So if you see here, in this same line nothing is survived. I'll show here. See, instead of order dot amount equal to 0, it just blanked out that with nothing inside this, but still it passed. Maybe I have to zoom. Yeah. Instead of this 3 lines, it converted it into 1 line and the test caught it, the test failed. So you know that mutation is killed, right? Like this you can actually go deeper and find out what actually worked and what did not work, and this can be a good score. The score that you see in the screen, this becomes a good way to measure whether you're writing good unit tests or not. Right? If you're writing good unit test, ideally it will be 100% will be the mutation score here, right? But it is different now, right? Because the unit tests are less than ideal, even though the coverage is 100%. This is the idea here, right? And what else did we want to show? Yeah, we also wanted you to take back something to your own teams so that you can showcase, right? So if you have a computer, or you can even at least take a screenshot and you can demonstrate here. But if you go to this screen, you can find a full setup of what is happening. So anybody wants to try out, you can try out and I can help you if you face some issues. But this will give you, okay, it's already here. Yeah, this is a sample project. I may have to zoom in. We'll close and start from there. See, this already has a sample project configured with all the setup that you have to have, and this runs directly on the web, so you don't have to do anything. I'm just zooming out. See, if you see, it already does all the npm install, all the things, and it will also boot up the UI for this particular project in a separate window. So this is the actual products window, right? It has some text box and all these things. You see here, something is there, right? Now, what you can do is, if you want to run the mutation test, you can just start here, and I have given the command also, right? I wrote a small script. You can reuse this in your own project also, right? So you can just say npm run striker, I don't know, striker report if I'm not wrong. I don't know what I configured it as. Yeah, it is right. And it will show you the report of the mutation test for this particular thing. So it will run the entire project. Maybe I'll show you how it runs. Yeah, the second thing. npm run. This will actually do the mutation testing now, right? And it will show you the live results parallelly, and later you can create a report out of it. I don't know why it is not doing. Typical demo problems. Let me restart. I'll go back to my slides. My internet is okay. So you can take that URL, and that will be a starting point for your team actually, if you want to start. And you can also tinker with it and learn some stuff about mutation testing there. So now this application is working. I'm starting a new terminal. Maybe I'll close the existing terminal. npm run striker. Yeah, now it is running. So it takes some time because it has to do a lot of computation if you see. So you can run it in parallel processes also, right? I am right now running it in single process, but you can always run it in parallel process to speed it up. Which is why this takes some time, right? So it's a good candidate for a nightly build. Don't put it in your CI build because then your CI will suffer. So put it in a nightly build, yeah.
Actually, you are asking us to, say, as tester, we should take the, once the developer has pushed his code, we should run it on the.
Ideal way is that you can probably have a idea of running, if you have a nightly build running, this is something that you can integrate with that nightly build. That way, every night you will get a report saying how your test coverage is, right? And what is the status of your unit test. And from there, we can get inputs as to what needs to change. And you can slowly work with the developers and train them in this also. That is another possibility, yeah. Yeah, good question. So the question is, how does it know what to change, right? So there are already strategies. It comes from the tool actually, but how they internally do it is, they already, ultimately it parses your code and finds out operators. That is one strategy where you change one operator with another operator. Sometimes it can even change the entire functions. And in Striker, you can even pick and choose what all things you want to exercise when you're doing a mutation testing. That configuration is available. So you can always go and choose and play with it also, what you want. Typically, it gives something, some default setting, but you can improve it also, what you want to change.
Let's say I'm dealing with something with an API,
Hmm.
and there are few acceptable payloads, there are few unacceptable payloads.
Yes.
So does it also work on text fields and other things, or is it just need to implement?
From my experience, what it can do is it can manipulate JSONs, because inside JSONs it's anyway going to be again constants and all these things. So it may change text field to null and it can still work. That is something that I've seen working. But you know, it does some basic stuff, right? And you can configure it to, you can pick and choose what strategies to use in order to fine tune that mutations that it does actually. But for that specific purpose that you spoke about, right? Contract testing is a different thing. So there are some tools which help you in contract testing. This is not going to help you in that. This may actually catch some coverage areas for that contract testing, but you should actually use contract testing for catching those kind of issues actually, right? And now the mutation testing is done and the report is there in this particular folder. So I will show that also to you. npm run Striker report. So this report is here, right? This is the same report that we saw. And if you want to look at it from a different browser window, you can always open a new tab and paste this URL. And this will give you the report and you can go and find out. And you can also try changing some code inside and changing some tests to make some of the tests pass. Accordingly, the code will improve, the coverage will improve, right? This is something that we can do.
So just adding to whatever Vivek told is, how do I motivate our team to, sort of use this? So one way is showing this actual demo, like, we can run this and show it to the team, and this is how we can leverage this. Another way is go and see some of the test cases, like we mentioned before. See some of the unit test, whether it is written properly or not. And when you test, some things are not working. And that exact basic, especially the critical basic scenarios, you can go and see what tests they have written. And once you see these things are not there, you can bring this up in retrospectives if you are doing Scrum, and ask the team how to solve these issues, and or you can suggest to avoid these things in future. We can come up with this, because developers today, some other developer is working, and tomorrow some other developer come and changes that code. We don't want that code to break, and there should be some protection. So these unit tests will serve as a protection, right? These are the ways you can motivate the team to actually use it. So there is yeah, I'll just summarize what we did, what we spoke till now, right? Yeah. So yeah, advantages of mutation coverage, like whatever Vivek already mentioned. One is it measures the true quality of tests. It just not only sees the coverage, it also sees the quality of tests. Like it intentionally introduces a lot of scenarios into your into your code, and runs your tests on top of it, and then creates a report. Some of the times you may have written a lot of good unit test cases by providing feedback to developers, but still there may be chances you might miss something. So these things can be useful. And the next is it's free of cost. You just have to, it's an open source tool. You just have to integrate it with your code. It's a little challenging in the beginning, but trust me, it's simple as well. You yourself can take it and run it in your local and show this report to your team. And yeah, can be easily integrated to your nightly build, like Vivek already mentioned. Another way is, since if your code is too big, the only challenge I see in mutation reporting, it takes a lot of time to run. So another way to do it is keep this build, keep this pipeline separately and run mutation coverage probably in the morning hours before the developer actually starts working. So before they start working, when they come, they should be able to see, okay, this is the mutation testing we have. This is the coverage we have today. We have only 60%. And another way is, just going back. So you have motivated the team to start, mutation coverage, and show them then, these are the things we can leverage from this. But where do we start? So we have code coverage of like 90%, but mutation coverage, we just have 20%. Now, where do we start? How do we improve that 20%? So there are a lot of ways you can do. One common way we choose was, we'll just take the main file, like Vivek already, you can show that. Yeah. So here you see there are a lot of files, right? You can, among these you can choose like, let's say that robber component is there, right? Robobar component. That component sort of is critical to our application. Let's start improving that file, and from there you can start. But you will face a lot of challenge from developers, because they have written, the problem is they have first written code and then they are writing test. So most of the code they have written are not testable. So that is the pushback. You will see a lot of pushback from developers. You may have to get the support from your management. I know these challenges may come, and get buy-in from developers as well. So these are the things you can use to, ideas you can use and see if you can implement. So I'll just, any questions till now? Any? Py test.
There is a
So,
question.
yeah. Sorry, can you come again?
I have not seen it being affected by the style of coding or design patterns, or even, sometimes it can, one thing that I see is, depending on the architecture, right? If you have an architecture, and also in microservices architecture, we have multiple things, multiple services, and maybe your UI is in a different repository altogether, then you might have to split it will not be a single mutation score for an application. You will get different mutation score for each repository you have, and you might have to do some kind of, aggregation in order to find out what is the general application's mutation score. But otherwise, depending on coding style, I at least per my experience, I have not seen it affecting anything as such, right? One common thing that I've seen is that, like he said, testability. Something may not even be testable, but your mutation would have done that, and in order to test that, they may need a lot of different designs in order to do that. Then, the only way to make that mutation be covered is to actually go and change the design to be able to test that scenario, right? And that will receive a pushback from a lot of developers, right? That's something that I've seen in the past. But again, not taking a very, activist kind of an approach helps, because generally we go in as activists saying, hey, this should be there. But instead taking a middle, ground, saying, okay, this is something that is not testable, so let's not aim for 100% mutation coverage. But any new code that we create for that mutations, I don't want any new, problems happening, and that sort of helps sometimes. Yes, yes, yes.
Yeah.
One more point I wanted to add about advantages of mutation testing, right? Most of the times when we talk to testers, I have been a Scrum Master, and I see a lot of testers in my daily job. They are overworked, right? Particularly before the release date, there is little to no empathy about whether a person can actually meaningfully work that time or not, right? What do you think leads to that point? There are multiple layers to it. It's not a single thing. But one thing that generally, in a common sense way, we say, okay, we want some basic test cases to be taken care of by the developers before handing it over to us. That's something that we say, but we don't know how to enforce that, right? And one way of enforcing so far was checking the unit test reports, but now we know that the unit test reports are also not believable, right? This is one way where the developer themselves will also feel confident that they have done something, right? It does not create a lot of drama, and you will get a little better quality than what you generally used to get before. And that can maybe marginally reduce the overwork that you are doing before the release, right? It is not a solution to all overwork that you do, but that can reduce the pressure even by a little bit, and that may matter to you, right?
Consequences are different when the developer experience is less than your as a tester experience.
Very good point, very good point, right? A tester, if he has to do a lot of manual tests, nobody cares. Something is manual, something is drudgery, something is totally boring, stupid kind of work, nobody cares because that's, people think that that's what you're supposed to do. But when the developer is supposed to take one more small thing that he has to do, it becomes a big thing. And that's the culture of, handoff culture, we call it, right? Developer, I've done my job, I'll throw over the wall, now tester, catch it and test it, right? That culture needs changes probably from the leadership and architecture level also, so that that does not happen. That's why we talk about that shift left, right? Where testers become an integral part of the user story. When you are starting the user story, you can start with thinking about test cases, right? And the
Also TDD will help
yes,
a lot, in this.
yes, correct.
Yes, you don't need to think about how do I write my code testable because you're already writing your code for the tests already written. So it takes care automatically. So another, yeah.
So if TDD is followed, we do follow in our organization. In that case, also we should bring about this mutation test.
Yes.
Certainly, it will help, right?
Even
Because
to get that code
yes, and the
perfect.
definition of TDD is not standard across multiple organizations. People think different things about that also.
And also developer to developer also
Yes. So typically TDD starts with writing an acceptance test. If somebody starts with unit test, it becomes very difficult. You need to write acceptance test, failing acceptance test, probably after that failing integration test, and then probably you can write a failing unit test, write some code, then maybe another failing unit test, write some code, keep doing the cycle until the integration test passes, then keep doing the cycle until the acceptance test passes, and that becomes one confident piece of code that you can actually trust with your life.
Yeah,
And
if you want to
repeat.
know more about that, you can buy our book. We have written TDD for Spring Boot
Spring Boot
microservices. So we have explained in detail with code samples how to implement TDD. So double loop TDD, all these concepts you can.
But all that knowledge is available on Wikipedia, YouTube
Yeah.
also. You can go and read
Yeah.
there also. It's fine.
You were asking something?
like in our organization, though they have done TDD, but it is something like you mentioned, pair programming doesn't come into picture. The only developer is doing TDD. So again, that gaps start coming there.
Yes.
So I think I will take it as a feedback that
Have you heard about Three Amigos? Three Amigos discussion, right? Start with a given when then format of features. That becomes your acceptance test suite, and you can parallelly do. But the problem with the in-sprint automation is that you always have the catch-up game to do. Last sprint we have not automated. Suddenly we cannot start automating this sprint. There is always this catch-up game, and that time never comes where you can always start writing from the first day, right? For that again you need help from your management and leadership to actually take a stand that okay, we are going to probably lose our productivity for a sprint or two, but then after that we'll start with a clean slate, and that is very difficult to get because of political reasons actually.
Although these techniques are very best in terms of like being a part of 21st century where we are blessed, like we have these TDD and context-driven development approach. But my question is a bit different. Like for example, consider a team where I am a tester having 3+ years of experience in the testing domain, not manual, not automation, but implementation. And you act as a developer and you are an intern over there. And at that moment in time, it is very difficult to apply that particular approach. I must say.
Which approach?
The TDD approach, because some unit test cases are not generally ignored by the developer at that moment in time. Because for that point in time, developer is always in hurry in order to deploy the code into the actual production.
Correct.
So at that moment in time, this particular technology failed because I practically implemented in my team and I
Yeah.
know that.
So for that, we need support from, the motivation from developers and support from organization, management. And one of the reasons what management says, we write test and then we write code, it takes a lot of time. But let's say we write code first and then we deploy. Everything works, everybody is happy. And it goes on for, let's say, 6 months. And then things starts breaking. And if I change one line of code, I don't know what somewhere, let's say I'm building a feature today, it takes just 1 or 2 days for me. And the same small changes after a year or so, I don't know how to do it in 2 days, because if I change a small thing here, I don't know where it breaks. So to maintain this constant pace always, so that, then we can use TDD. And also the cost of fixing bugs, like Anand told, once it goes to production, it will be huge. And you can tell this cost, the cost effect, right? If the best way to catch the bug is in the developer machine itself, even before it integrates. So these are the ways we can sort of motivate the management and tell them that these are.
Here one loophole is still there. For example, in few of the organizations who are like in service based, I'm not talking about a product based one, because they have a customization via workflow where they have a testing environment, staging environment, which is a replica of production, and then production environment. At that moment in time, tester has a confidence level like, yes, I can do testing on production environment because somewhere I have a backup of staging environment. But in terms of service based organization, like in cloud based projects where certain deployments are daily on daily basis, I must say, because of us, you can say that a field change, label change, and so on and so forth. The list is very long.
Yeah.
At that moment in time, TDD fits. I personally believe, because certain deployments does not allow tester to perform testing on it. At that moment in time, we can't divide our test cases into high level and low level.
Yes, it is always a function of technology and what your development environment can offer you, right? For example, Salesforce is what probably you're talking about, whether you can do TDD in Salesforce. I saw you quoting Salesforce before in the code coverage, right? So there is very limited amount of TDD you can do, because all test you can do is probably at the REST API level. If you're talking about REST APIs, right? You cannot go deeper and say, okay, this is particular thing that I can do. And even if you do, there are a lot of limitations around what you run and all these things, right? So it is always a function of what your language choice, technology choice, all things leads us to also. Sometimes we are stuck with the choices that someone else has made, right? And that's not our fault. In that case, we'll try as close as possible, as much as possible, so that we can get better. But it's not going to help if the
It's only one scenario is there that I personally see from my experience. That is totally worst case scenario. Your testing billable hours. That plays a vital role. If your company has a control on that particular area, you can be a very good tester.
It all narrows down to economics. So
yeah.
so any questions till now? Yeah.
Not related to this, how do you see code coverage in a functional test or regression test?
When you do functional test or regression test, right, by definition it is a black box test, right? We don't want to go into, and ultimately it runs on a software that is already built, right? Maybe it's already been built into a jar, or it's already been built into something which is not code anymore, right? Now, when you want to do code coverage there, then you might have to have a specialized mechanism of not running it on a jar, but you have to run it again on the code, which again is a problem. So generally we do not generally recommend code level coverage for functional tests, right? Which is why the unit test and integration test play a role. There you can probably have, generally I have seen people reporting coverage as a percentage of these many scenarios are possible, how many scenarios are automated. That's the level that I have seen. But when you want to do it at a code level, it becomes very tedious, and I don't know whether it actually pays off. I would rather expect people to spend that effort into pushing things down into unit layer than trying to put it in the end-to-end altogether.
Unit layer, it is always there, but what I see here is when you have code coverage there, one thing is you can enrich your regression, right? Because let's say you are running regression, and as a tester we are always confident, no, I have done 100%. Correct. But you see only 30% of your code is getting covered when you are running the complete regression, right? So I can add more scenarios there.
Correct.
Other thing I can say, there are 30% junk code sitting there in my code base.
Yes, benefits are always there. No argument about the benefits of instrumenting code coverage. there are techniques there, but they are, what do you say, they are overly complicated to the point, and it takes the focus away from unit test, which is where you probably need to focus on, because ultimately if you want to get confidence on the product and you want to write massive end-to-end test cases to get that confidence, then it is going to be a very long running test case, because you need a database, you need all the servers up, you need all the third-party services up, and then you will start running the test cases. Whereas if it is in the unit test case, it's going to run very quickly. So best bet is always to write it down in the test pyramid and up.
The reality is that most of the companies don't write.
Exactly, this is the opposite of the pyramid, right? Manual is the most and unit test is less. And my day job as a consultant is to invert the pyramid for multiple companies. So I go there.
Cost of fixing that also, if you find some bug,
Yeah, yeah.
and then the whole cycle repeats. So that this is another way to ask them to do TDD.
Yes.
Again, this is another, because fixing bug is also a huge
It's a very difficult task to make management understand that unit testing is mandatory.
Correct.
But okay, due to like delivery pressure or something, they'll
Yes.
say, okay, ignore it, test karo and release.
Yes. They have high confidence on you. They have less confidence on the developers. So they are taking that bet possibly.
Even for QA, it is not that the case, right? You will hardly have time, and they'll say, okay, just see the happy path and release.
Yes, and the last minute only you get the builds. You don't
So,
get builds before.
sorry, we just have one more minute. I'll just summarize what we discussed till now. So we discussed fundamentals, what is code, what is test, and what is a good test, what is a bad test, how can you fake, code coverage, what is code coverage, and problems relying only with code coverage. We are not telling code coverage is a bad metric. You can use it, but don't rely too much on it. And then what is mutation testing, how to implement it, and some ways to motivate your organization how to use it, and then we also showed you a demo, so you can take that link and
Yeah,
yes, sure. So yeah. Yeah, this is the link. You can note it down, and we'll also pass the slide deck to the organizers. You can take it from them as well. So so please connect us on LinkedIn. My name is Kiran Kasyap. His name is Vivek Ganesan. So he's a very nice guy. Don't worry, he'll help you out if you ask. So he's mentoring me from past 2-3 years. So feel free to reach out to him. So yeah, don't
and
scold
catch
me.
us while we are having lunch, or we are going to be here for the next this day and tomorrow also. So if you want to catch up and probably have some more conversations like that, we are always up for it. Thank
And
you.
please let us know any feedback if we could have done
Yeah.
this in in any better way. If you missed something, please let us know. So thank you all.
To give the same demo if our company invites
Why not?
you.
I do
So
that
it
also.
will be remote because it's
Yeah, yeah.
UK based.
Perfect.
Will you do?
Yeah, yeah,
Okay,
certainly.
so I'll get in touch with you
Sure.
once I get this
Thank you.
ready.
Thank you.